This is Team CREED, which stands for COMSOL Researched Extreme Environment Designs. The team includes Mia, Dominic, Joe, Aaron, and myself. Our sponsor is Dr. David Estrada. He works in the Advanced Nanomaterials and Manufacturing Laboratory, working with nanotechnology and bio-nanotechnology. The group uses COMSOL to simulate models.
So just to give a little background on what COMSOL is, COMSOL stands for Computer Solutions, and COMSOL is a finite element method tool. And Dr. Estrada's lab uses it to analyze and design printed sensors for extreme environments. But broadly, we can say that COMSOL uses computational models to predict real-world scenarios. The basic workflow that COMSOL users use are first to create and load a geometry. The second is defining a model, and the third is simulating. And these two figures on the right show the COMSOL model of an electronics closure. And loading the geometry was just like uploading a CAD file, and defining the model includes identifying materials used, the enclosure and sources of heat, as well as which direction air is flowing in and out of the system. And after simulating this model, the output is shown on the bottom right, and we're able to see how air moves through this electronics closure, as well as the degree to which each component is getting heated. And that's a very, very basic overview of how COMSOL works and how it can be used to simulate and analyze different systems.
So the main big problem that our sponsor wanted us to tackle was the fact that training yourself on how to use COMSOL was a very lengthy process. The current graduate students that are working under Dr. Estrada were tasked with learning this software on their own time, which isn't really easy. And just because it isn't easy doesn't mean it's technically impossible. COMSOL does provide a lot of how-tos and lengthy seminars that go over both the basics of COMSOL and detail the modules within and how to use each and every one of them. However, what we wanted to do is to take that training experience and condense it down into one easily accessible package that will work for both graduate students, undergraduate students that are wanting to get a grip on COMSOL in a faster timeline.
To help solve this problem, our goal was really to speed up the process and condense the information needed to train oneself in COMSOL. And so we really wanted to include geometry and other analysis techniques within this. We also wanted to introduce finite element analysis, and then also organize the modules that we're going to be providing that will include like the COMSOL PDFs and seminars, and also some step-by-step training aids. And so ultimately, this whole training aid will really help the students learn COMSOL faster, and it will provide a better understanding of the fundamentals of the software. And so at the end of the day, they'll be spending less time training themselves and more time actually doing the work that they need to be doing. And this will be awesome because it's not just a one-year thing. This can be provided to future graduate students and undergraduate students time and time again. And so our solution was that we created a tailored website to meet all of these objectives.
The website that we have created goes over a brief introduction into finite element analysis and how it is used in COMSOL. Our website is tailored to Dr. Estrada's research group, and because of this, it covers only the modules that they use. This website introduces these modules and provides links to COMSOL-specific tutorials for advanced information.
We would like to give thanks to the people listed below for all of their help with this project and hope to see you during our showcase.